So, I also hope everyone enjoyed their barbecue. Now to the business. So, I'd like to tell you something about events and event sourcing and what next. So, what you should do with them. Why? Oops. Sorry. Why? Because lately at Ruby conferences, there's like a lot of talking about event sourcing, about events. Here are some examples I found from last 2 years. Many of those were local, but not all of them. So not every Ruby conferences, but many of them has to have something about event sourcing, and for this conference I provide. But all those talks about event sourcing has one flaw in my opinion. So they tell a lot about theory, about what event sourcing is, how it should look like, and then always there's this Q&A session, and someone asks, "So how should I start? I have this monolith in Rails. I want to do event sourcing, but because it's so cool, but how do I start?" And the answer is, yeah, just start sending some events when you update your models, and start saving those events into event store, and then you'll figure it out. And it's good advice, I give you that. It's good advice, but then we fast forward 1 year, maybe a bit more, and you have those events alongside your relational database, and you actually need to figure out what to do with them. So this is a story of doing it, of having an event store alongside relational database, and putting it into a production working software, powering a company that deals with a lot of marketing worldwide. So to not go in some kind of void, we need to start with an example. So suppose you have a very simple ticketing system in your company. So you create some tickets and you want to track problems, track how those things that tickets described are solved and are progressing. So this is how part of your probably tickets table in relational database would look like. We have title, we have reporter, we have assignee, status, created that, updated that. It all looks pretty familiar, I guess. And when we choose just one record from this database, we also have some kind of history. There's no created at, no updated at. Instead, it's a timestamp, and we can see highlighted in red, I hope you can see, which fields changed from the previous captured state. But this is also not really an event store. This is more like audit log. We know that. We have used things like paper trail, for example, which does exactly that. But this is not really event sourcing. Events in event sourcing would look more like that, so that they have some kind of name, ID, and on each event there are some subsets of fields that are important for this event. So when you create a new ticket, you obviously need to set all the events to initialize the ticket. But when you assign a ticket, you only are interested in who is the new assignee. When status is changed, you're only interested in status. So this is what our events in event log would look like. But now we have two databases. So when we are going to show like a general view, when you can filter on events, on tickets, and show only those which are in progress, or only those reported by John, it's cool. We can use relational databases, pretty good at that. But when you enter the view of single ticket, you can use this event database to show how the tickets change in time. It's done by Jira, for example, so it should not be very foreign for any of us. But two databases, what does it mean? It means that eventually you'll end up like this, trying to figure out which database is right, because they have different data in that. One database has status done, but in event log there is like no transition to done. Last action was that, for example, Katie assigned it to hers, but it's still in progress. So you have different data, and you need to figure out what happened, why why it happened, and on top of that, you need to figure out which is correct. Is the ticket done, or is it still in progress? So event sourcing makes it simple. Event database is always right, and it's very, very important to remember. And this is like one of maybe 2 or 3 very basic rules for every event sourcing system. So if our event database is right, but our relational database, or we can call it read database or whatever, says it's different state, says it's done, while our event database shows that it's not done. So you need to have some way to recreate relational database, recreate current state, because okay, let's stop for a moment. Now back to events. So we need a way to take those events in our event store and actually update the state, update our relational database which holds the state from those events. The usual approach advertised in those talks, advertising tutorials. So you take all the events, and one by one you take one event. You have a function which knows what to do with, for example, assign event. When you have assign event, you just take your virtual object of your ticket and change assignee field to what is in this assign event. You do that for all of events, and finally you have a bunch of virtual objects which you can persist to the database or pass to the view and show to the users, whichever you like. That's cool, but it takes very long time to do if you need to do it every time you need to show something. Even if you use snapshots is a technique to avoid that partly by taking a snapshot, for example, daily. So you save last known state and you apply events only on top of that. So this is of course faster, but when you have a lot of events, it's not fast enough. So you can't just rely on that. So here how we dealt with this kind of problems. This is a rough image of how our system looks like. We have event collector, which is a part which gathers event, or rather events are sent to it. This is an HTTP endpoint, the only one facing the web. And we have very, very many clients to this service. We have our internal apps, we have our mobile apps, we have external integrations such as point of sales, such as Wi-Fi vendors, portals, such as completely strange external integrations, and all of them sends events here. And this is when it lands in our system, and this is when we take over. We need to do something with that. So as you can see in the picture below, the event collector is saving to event store. This is like the most important operation, and only when we do that, it's very hard to capture in the picture, so I decided not to. Only when we do that, we consider event acknowledged in the system, and everything else happens after the event has been saved into this event store. And what happens then? We also trigger live processing, which actually takes an event and applies it into our relational read database like live, not in batches, not once per day, not when it's needed, but more or less from the queue of events, it updates this read database. And like I said before, you may see the problem. Those databases will eventually, inevitably, have differences. And that's why we need the fifth element here, which is this full reprocessing, which is anyway needed to create initial read database. And this is pretty much what I say, it takes too long. So it takes all the events, applies some transformations, and saves the clear new current state in the read database. So these are 5 parts that get us running. And running quite solid manner. We don't lose events. Sometimes we may make mistakes, but we also always recover from them. and we also can sleep at nights, which I guess it's pretty important in that job, because like I said, even if I make mistake, there is usually a way to make it right without doing all those kinds of crazy manual migrations, etc. So let's talk about those components one by one. So events collector needs to be really highly available. This was a problem in old system, because to give you some background, I came to the company, I was given this event store. There were two of us in the newly created team, and we are given the task to do something. We have a legacy system which tried to do something and failed miserably. So the main problem in this old system was that it tried to apply everything during the request response cycle. So so HTTP endpoints got overloaded. They took a long time. So at some point we started to reject requests at all, and this is like no go. If you have such thing as events collector, it needs to be up 100% of times, and the request should be short, so we never have a situation when some requests are dropped because we don't have capacity to accept and process it. To achieve that, we choose Grape plus Sidekick. Grape is, as you probably know, a library to create JSON APIs in Ruby. It can sit alongside Rails if you want, but we use it on its own without any kind of Rails next to it. So all it does is just validation and putting jobs in Sidekick, and Sidekick does heavy lifting. This way we can maintain this responsiveness in the HTTP endpoint, and Sidekick does all the heavy job and does it well. Why Grape? So perhaps Rails would be enough, like Rails API or something, but better safe than sorry. We had bad experience with Rails. We decided that we needed as lightweight as possible. We ended up rewrite some parts of Rails, like migrations, for example, and repositories, but it's still, I guess, a good call. What it does, so it checks some authorization headers to see if this integration is our integration or just someone from the internet, and if this integration can send this particular type of event. So it's one database call to do that, and we are working on having a cache in Redis to make it even faster. It performs very rudimentary validations on those events. So basically, events are things that happened, and you don't get to decide if they happened or not. They just happened. So if someone sends you that transaction was made at some shop with this point of sale terminal, you don't discuss with that. It happened. But you need to perform some simple validations if all required fields are present, for example, so you can reject just incorrect payload. I mean incorrect not logically, but formally, so the integration knows something is wrong, and they can call you and ask you how to fix it anyway. And after doing this, we schedule a Sidekick job, and that's it. Those request times are around 10 milliseconds on average, and this component never failed since we deployed it a year and a half ago. Our traffic is very peak based, so it can have, for example, usually like 1,000 requests per minute on average. By when the peak comes, generated by something marketing related, we can have 10,000 per minute, and we need to be prepared for that, and it does its job. But I wouldn't choose Grape again, mostly because its validations proved to be not enough for our more complex cases, and we ended up mixing Grape validations with Hanami validations or dry validations. It works, but it's kind of hacky and makes it hard to test, because some validations lie in Grape layer, which is basically an HTTP layer, because you only can test it with end-to-end test. And some lie a little bit lower, so we could test it on its own, but then there's problem with integration, etc. So while Grape does its job well, its design has some constraint, and probably we will choose something else again if we were to choose again, but I'm not sure what. And Sidekick, well, just works. I don't know what to say. It processes billions of events for us. I believe now we have processed 700 billions since this year and a half, and just works. So why not use it? Okay, next thing in the picture. So we have event collector. We have some events saved in our event store. So what we need to do now is we need to create initial read database. So we need this full reprocessing or processing for the first time. This, in our case, is custom script written in Ruby, which we would like that it does what I told you before, just takes maps event type to some function and performs it on just an object in memory, but that would be too easy. It's not performant enough, so we had to do some optimizations using RocksDB and Redis as a throwaway databases during that process. Redis because it's very fast, but it needs to fit in memory, and we can't afford it because we have too many events. So we also use RocksDB, which is pretty great choice when you need to have a fast key value database written to disk. It's optimized for SSD. It's developed by Facebook. It's relatively unknown in Ruby community, but because it's embedded database, so you built in the process. So if you have, for example, 4 instances in Rails, which is a common pattern in Ruby world, you cannot just use one instance of RocksDB because it's different kind of database. But for our purposes, when we have just one script running in one process, it's perfect. And the result of this full reprocessing is CSV file, which we then copy to Postgres. Copy because it's like way faster than doing inserts. And actually this part, everyone is surprised how fast it is because we generate like millions of records, and copying it is several seconds. Then we create indices, etc. To make this process as quick as possible. But it has its problem. This is one of rare, maybe not so rare, but also not that common cases when Ruby is slow. And it really is, it's not just a slogan, because I tried to rewrite this in Rust, and it was twice as fast. But the part I rewrote, it was mostly just parsing JSONs from HTTP request to Elasticsearch, and doing minimal transformations. It was not any kind of heavy calculations, and putting it in RocksDB and just not using Ruby gave us twice as much performance. So yeah, it's one of those cases. But it works. So we need one last missing piece, which is live processing. For that, we chose Kinesis plus Lambda because we were on AWS anyway. The Lambda is written in Python, so we can't reuse code used in this full reprocessor, but you couldn't reuse it anyway because it does not need to be that optimized. Actually, it's easier to reason about it when it's not. And Ruby was not available on Lambda back in the days when we wrote it, and there was no need to rewrite it. So this was experimental setup. Kinesis is just some queue, and Lambda is just serverless functions for those who don't know, and they connect really well together, and we don't need to care. So this is an upside that we don't need to care, but this is also a downside that we can't care because it's kind of a black box. And sometimes behave in a way that documentation does not suggest it works like that. For example, Kinesis has a concept of shards. So the more shards you have, the more events you can process concurrently. That's the theory. And it suggests that when you put twice as much shards, you should have twice as much performance, because you spawn twice as much Lambda function, but you don't. You can see from the logs that spawning Lambda functions is maybe 1.2, 1.3 times more than when you use less streams, but you can't guess why, because you don't have access to any kind of logs. Still, What it does is just take event, create SQL query from that. We don't use any kind of models in between because we don't need that, and apply this SQL to our read database. And we haven't talked about one thing from the picture yet. We also haven't talked about read database, but this is just Postgres, so you all know that pretty well. So event store, this is the very important place when you keep all your events. You should not ever lose them. You should not ever have problems writing them to this event store. Traditionally, when I watched some presentations about event sourcing, those are some choices that that are quite common. So some people use also relational database because that's what they have, that's what they know, that's what their DevOps or administration knows. So they stick with the technology they know. They just create another database called events, or maybe events mobile, or events whatever tickets. But they still use Postgres or MySQL, whatever. Recently, Postgres has some features towards that. I haven't examined that, but clearly developers of Postgres want people to use Postgres in that way, and they have some optimization for append only structures in Postgres. Most popular choice is this project called Event Store, which was for a long time available on Windows. Now it's not, but it's advertises as designed exactly for that, for storing events in a performant fashion. Some people use Cassandra, some use MongoDB. So guess what we chose? We chose Elasticsearch, or actually it was chosen for us because, as like I said, when I came to the company, we already have this event store, and it was in the Elasticsearch. At first, I was surprised. Why? Is it like they knew the database and they just used it, or what? And I don't know, because those developers did not work when I came. But actually, it proved very good fit, and now I can advertise Elasticsearch as a event store. A little bit of context, it was created to support full text search and is used as that for in many companies. So you just put your records or snapshots of your records in Elasticsearch, and then it has quite impressive set of tools to do full text search on them. But it also has been adopted for logging, for centralized logging in multi-tenant systems. So it's E in Elk stack. Elk is Elasticsearch logs-kibana. And it's also pretty popular setup in many companies. I would say that nowadays Elasticsearch is even more advertised as E in Elk than in full text search, but those are two most popular applications of Elasticsearch. Why I say it's almost perfect? So it can easily handle a really large amount of data because it's for centralized logging. You can imagine that in such companies there are hundreds of logs, of thousands of logs per minute. So it's designed to handle that. It's optimized for that, for appending only. So it's fast operation, and indexing and all this happens in the background. So it does not impede your saving. It has this good search and filtering capabilities, which are maybe not that useful in event sourcing, but kind of help you in everyday life. Anyway, you can script it in Groovy to do some more complex things. It's for kind of like maybe views in database, kind of like triggers. You can do pretty complex stuff if you make yourself write in Groovy. And you get Kibana for free. I will tell more about it in a minute. But it also complicates to set up properly because it's easy to set up, but it's complicated to set up properly. You need to have enough balance of data nodes, computation nodes, master nodes. So it takes some time. It takes some work of your DevOps department if you have one, or of reading Stack Overflow or whatever if you don't. Its query language is JSON based, is terrible. I mean, really, it's optimized for this full text searching. And if you, for example, need exact matches, you need to. It's not like just where. You need to tell it that you need exact matches, for example. And what we learned, extensive scripting, this in Groovy, I praised seconds ago, can kill your servers, especially if you didn't set it up properly. So it's kind of one and another are together. Because those scripts are executed just on the server. If you didn't set it up properly, it can execute on data server. So your data node, this node may become unavailable. This triggers resharding, rebalancing, etc. And it can render your whole cluster just unavailable, which is not good. But this only happened when we used some very complex scripts which tried to go through whole history and calculate those the state of the database on the fly, for example. So if you use it reasonably and don't abuse it, you should be fine. I talked about Kibana. Kibana is a web application to query Elasticsearch to make accessible view to data stored in Elasticsearch. Again, it is K in Elk Stack, so it's optimized for logs. You can search, you can filter on some fields, you can make some visualizations. You may wonder why, but I've heard many people wondering that they have their event store, and what they should do. They just don't know the way how to look into the data, how to. Sometimes you need to check your data manually because you have some suspicions that something could be done better, or someone send you some fake data, or you don't have fraud detection, so you need to go by hand because someone calls you from business that, hey, we have this user, he's suspicious, check what he did. And it's hard in those event stores. Especially in event store, it's hard to do. So having Kibana helps a lot. We can also have some visualizations, for example, how events distribute over time. This can be also useful for non-tech people. And we were able to teach some non-programmers from our company to use that. So when they have questions, instead of writing to us, they learned that sometimes they can fire up Kibana and search themselves, which was pretty cool, and still is. And they use those visualizations sometimes too. Also, it's faster for us when something seems to go wrong. For example, classic example I told you about, we have some state in read database which seems incorrect. First thing is to check if the event store is correct. So with Kibana, it's way faster and easier than just firing up Postman and constructing query to Elasticsearch with this non-developer friendly language. And you cannot break anything with Kibana, so you can easily give it to tech people, to non-tech people, or you can experiment with it yourself and never care that something will go wrong, that you overload the server. It's pretty safe. But there's more. You can update records in Elasticsearch. Again, for example, with Event Store, there were many histories about that when GDPR came. That you need to get rid of personal data in your event store. What to do? Event store in theory is immutable. So what should you do? And classic answer is just take all the events, process them again, put them in the new index, meanwhile removing personal data. You kind of can avoid that in Elasticsearch because you can do regular updates on your records. So it saves time. You can delete records, but they make it more difficult than it sounds, fortunately, because sometimes we also were on the edge of deleting something or everything. But yeah, it saved us few times, just the possibility to update records. For example, when we needed to set processable flag on those events due to GDPR, so we could just update all the events older than date when GDPR came into force. with true, because it's legal as far as I remember, or to false. Anyway, we did what's legal. Let's just stop there. Also, Elasticsearch is widely supported around the world. You have a lot of libraries. Every language has a library to work with Elasticsearch. Some are not great, but many are good. You have connectors. You can connect directly to Tableau, to Power BI, to some kind of other business intelligence tools, and the data just goes there. You don't need to write any kind of integration yourself, which is also useful. And again, it's designed to handle massive amount of data, and it does. So to give you some numbers, how we do. We have 1.8 billion events to date from last 4 years, I believe. This is 690 gigabytes of data. So as you see, it's not like crazy numbers, but it's most than regular software house project, I would say. On average nowadays we have 2.8 million events per day. This is an average taken from last week, but there are some weeks like Black Friday week, since we do it with marketing, so there is like much more activity then, so it rises to 5.1 million events per day during this week. It was last year. So this is the numbers we deal with. This is the numbers when this full reprocessing is enough, when Kinesis plus Lambda with 4 or 6 shards is enough. I don't dare to say it scales infinitely. Probably not. Probably at some point when this rises 10 times or 100 times, we need much more complex full reprocessing, balancing into many servers, because we wouldn't be able to do it, but that works for now well with those numbers. So most important lessons, because like I said, we deployed it 1.5 years ago. Since then it works. Since then we made a lot of improvements there, but there was no like a total failure, total downtime since then. But what are the most important, according to me, things that we learned from designing a production working event sourcing system? So first thing, don't try to event source everything. I know many people, myself included, coming from the conference. Hey, there was a cool talk about event sourcing. Let's do this. Oh, let's write a blog in Rails with event sourcing in 60 minutes. No, that's a no-go, because blog is just not the thing you need event sourcing to, and you will spend a lot of work, and you will gain nothing. You couldn't just have by using relational database and maybe audit log if you need to revert to some earlier version of the post, for example. But basically event sources won't help you with everything. There are some applications when it's cool, there are some that it's not. For example, we try to event source profile data, basically things that people put in their profiles on the website, and we deleted it after a few months because it was hard to maintain. We had some list of personal data, non-personal data, but this list went out of sync, so we needed to go back and manually delete personal data that got into our event store, which, like I said, is possible with Elasticsearch, but still not something we want to do. And after a few months, we just decided we don't event source this. We delete events about updating profiles. We sync profiles from the profile database using replicas or DMS on Amazon or whatever, but we just don't need that. Write a lot to your event store. It's cheap. If you wonder if you should include this particular thing in your event payload, do include that. Because it doesn't hurt, but only use fields you actually use in your business logic in the read database, because relational database tend to get weird when they are big enough, and having unused fields contributes to this big size without being used anywhere, so updates can become slower, etc. And you always have this full reprocessing if you need to add something new from your event store to your read database, actually. So you are safe to go. But when you don't write it to your event store, it's lost forever. And it's this common case when business comes, hey, can we start to track this and that? And you say, yes, from 2 weeks from now, maybe we can. If you were wise and stored everything you could in event store, you can say, yes, in 2 weeks you will have this tracked for whole history. So that really makes a difference. And make mistakes. This is general advice because we won't get it right in the first go, probably. We did not. We made a lot of mistakes, but they were not touching writing things to event store. We never rejected the correct data. We never failed to write something that we acknowledged to event store. So this was the part where we were extremely careful, but the rest you are pretty much covered. Because in this ugly green thingy is the code where you can code or infrastructure record, you can easily make those mistakes because there is always a way to recover from them. If you have wrong database layout, just fix it and run this full reprocessing. If some events process in wrong order, by the way, you should also always have timestamp on your events, so you know correct order. Just fix the code that sorts them in order and run reprocessing, fix live processing, and you will be good to go. Of course, for some time data will be corrupt in your read database. In our case, it's not a disaster. Database down, this relational or lambda for some reason down, no problem. We detected the most important thing the system does is to persist events in event store, and as long as we do that, we can deploy on Friday 5 p.m. and go home and not take any calls until Monday, because we know that we will recover eventually. It's not like if we don't fix it immediately, we will start to fail at delivering most important feature of the system, which is accepting events from all this kind of external systems or internal systems. And that's basically it. Thank you.
Any questions?
Thank you. Do you, when you get a business requirement, you need to implement it once in Lambda and once in the, like, you have the query part, right? And you have, so you need to implement the business requirement twice, always?
Yes.
Okay.
Like I said, it could be partly avoided if we had Lambda in Ruby, but with all those, we will lose those optimizations probably. So we actually, to have a system in running state, we actually, we are okay with having to implement it twice.
The question about the sequence of events. So you have said about, actually initially I thought if you put it to the sidekick, how do you really manage the consistency that sidekick didn't process event, so event A, B, C, but it wasn't processed like CBA or something like this. So as you said, it's timestamps. As I understand, client should put the timestamps. Or who is putting the timestamps?
Actually, we use two timestamps. So first timestamp is when the client thinks states event happened. Second is the timestamp when event arrived to us. The other one is rather used for debugging, but we have a system in place to avoid such a situation. So I would need to go back a lot. But actually sometimes it helps to have all possible fields here. So even if you only change assignee, you anyway put all other things in the state that this integration thinks there is. And also in the database, read database, you use this updated at field. And if the event you are processing right now is older than last updated at, then basically you frequently can discard it because those changes were already included in the next event. This is one of the strategy. This is not always possible, but this is one of the strategy we applied to deal with what you say is obvious problem that you don't always process events in order. Other, if we really need to maintain the order, we can substitute sidekick with something that guarantees it. So, for example, another kinesis or RabbitMQ, we do have some corner cases when you do that. So we don't use sidekick because we need explicit order every time. But generally, if your events are from the real world, so I give you an example of actions in mobile app. In mobile app, we track things like entering this screen, entering profile update screen, entering coupon screen, etc. It doesn't really matter in which order it happened. It matters for business that we have marked that this user and watched this screen in last week. So so it kind of depends on events. Sometimes you can give up on processing it in correct order.
Yeah, actually, I was talking about more about events like somebody said updated some entity and also deleted, but delete processed first and updates the second.
So this case is easy. If the event is deleted, you know that something happened. But yeah, I hear you. Yeah. Anyway, we have some things for that, but they are quite complex to explain just like this. Sorry. Basically, you need to figure out this case, and in this case, probably like I said, you wouldn't use maybe sidekick, but some other queue, or just sidekick with one worker on this queue.
And one more question about reprocessing. Can you please explain? Is it like a completely process of the whole queue of events, of this full reprocessing? What do you mean by this? Because
you take the event store, you set up a clean new database, and you process event one by one whole history. So you have database in 100% correct state.
So the whole actually 2 billion of events?
Yes.
Oh, cool.
Anybody else?
Yeah, you talked that the read database sometimes get inconsistent due to the disasters and etc. What other sources of inconsistencies do you have? Maybe developer errors or something like that?
Yeah, one source is when we didn't think about correct order. That was the case, actually, in the beginning. Developer errors, yes. Also,
I mean, you have profiles, right? And this read database, it is truly read-only, or is it used for by the web portal in write
no.
mode also?
So live processing in this picture is the only project that is allowed to make updates on this database. The profiles we sync from another database, which is basically just a source for events.
So in other words, the only reason the read database can be inconsistent is lack of live processing, disasters, things like that.
Yes.
That you don't control.
Yes. Oh, maybe programmer mistakes we do control somehow, but but yeah, it's not like there is another tenant which did some unauthorized write to this read database. Live processing is the only process application that is allowed to make writes to this database and full reprocessing to when it's needed.
Anybody else?
Thank you, Paweł. Small question. Maybe I missed that. On what models do you use this event store?
Models?
Yeah, like from what logic? You said you're tracking users, right? So that's your use case.
You mean what the company does business-wise?
Yeah.
The company does loyalty programs and marketing for mostly for malls, shopping malls. So every mall gets their own app from us. We send emails to the loyalty program members. We send SMSs, so we track opening emails, clicking in links, activity in the apps, activity in the store if they have such integration, because some have like physical loyalty cards which you just use when shopping. So either manually or automatically it sends us events like that. So it's this domain.
Thank you. Makes sense.
Okay, last question. Okay, so you mentioned that the event collector has to return as fast as possible.
Yes.
Do you have any cases, probably not in this like business model, but do you have any cases where the client has to know that the event was processed so that it can like mark it as checked, done, or whatever?
Yeah, I was kind of hoping for this question. Yes, we have, but we need to add one more piece to the picture. If some integrations needs full answer, if this event is correct, unique, I don't know, not too old, which requires more validation than just seeing its structure, than just formal validation, we set up a proxy before event collector, which does those checks for us, returns to the integration. But it can, if it's too much traffic, it's only for one integration, which explicitly told us to do so. So we are kind of safe that they told us to do that. If it makes problems, we don't work like this. And if this proxy returns okay to the integration, it also sends the event to event collector. So this is the way to avoid that. Other way, but no one decided for it, it's to subscribe to some callback that events was processed.
Yeah.
So we could, and we have such mechanisms, but no external integration. We have some internal integrations that use that, but no external integration never decided to implement that.
Do you use anything
Yeah.
specific for it, like any libraries?
No, actually, we wrote it ourselves.
Okay, thank you. Okay, so one last question.
Hi. My question may seem quite trivial. You showed us some examples of these events. They are named created, assigned, etc. When we have a large system, there may be a very big collection of events, many different types of events. One of software development's patriarch once said there are only two hard things in computing. It's cache invalidation and naming things. What are your hints to name events so there is no mess?
You mean, for example, you have ticket create and comment created, and you named one of your events created, so you cannot make, and you need to name another comment created, and it's inconsistent, for example?
That's right. Probably you are using some kind of namespacing, but in general, what are your recommendations?
Well, in general, the name of the event should be pretty much natural and just say what it does. We have everything scoped by the scope. So if it's mail opened, we know it's mail opened, not push notification opened. So yeah, for us it was enough to use namespace and just natural name for events, nothing fancy.